Right, this is lecture 8 on Calculus 2, and it's on potentials, and it also has implicit differentiation. And it's a very long video actually, I'm guessing. Right, first off, this is just a definition of potentials. Now in the last video I did a little thing at the end, an example, because I wasn't sure whether he was going to teach it or not, but he has taught it. So if we have a function f which is the gradient of another function, then it might be a continuously differentiable gradient if dv dx equals du dy. Now v is like the x of the second function, and u is like the x of the second function, and v is like the y. This is a scalar field, so it's put in the form whatever I plus whatever j. Right now, if dv over dx equals du over dy, then it could possibly be a continuously differentiable gradient. So we integrate u with respect to x, and don't forget your constant, and then you differentiate with respect to y to go kind. It's like going backwards kind of, and you'll have your constant, and you're differentiating your constants, so you'll just have a little dash, and equate this to v. This will make sense. I've got an example in a bit. Work out your constant. You probably have to integrate a bit and give your final answer. This is the potential for f. This all makes sense, hopefully. Right, first off, is f of xy equals 3x squared yi plus x cubed yj a gradient vector field. Now if it's a gradient vector field, it might be if du over dy equals dv over dx. Now I remember it because u couldn't look like a y and v is like half an x, so we have to check whether they are right. So if we differentiate this with respect to y first, we'll get 3x squared. Differentiate this with respect to x, we'll get 2x squared y. Oh, 3x squared, oh sorry. So they don't equate, and therefore it is not a gradient vector field. Right, another working example, this one will work. So we want the potential for 2xy plus cosine xi plus x squared minus sine yj. Remember, we have to differentiate this with respect to y and this with respect to x. So we differentiate this y, which will give us 2x, so this will cancel out, it's just like a constant. Differentiate this with respect to x, that will give us 2x. So they do equate, so it might be. Right, next we integrate this with respect to x, which will give us x squared y minus sine x, plus sine x plus cx. Cx is our constant. I've put the x just to remind us that what it's part of, because we got it by integrating with respect to x, so it's going to be an x function. And then we differentiate this with respect to y, so this has just become a constant, that'll cancel out. This y just disappears, so we're left with this, and we're differentiating this as well. That all makes sense. Then we let this equate, this is all on the first slide, we let this equate to this, that we have here, and then we rearrange it a bit to get c on its own, to c prime. Then what we want to do is we want to integrate it, and this will give us c on its own. Yeah, so if we integrate this, it gives us minus x, with respect to x, because we've got an x here, minus x sine y minus x cubed over 3 plus d, and you're right to have a d there. And then we put this c value in here, and this will give us our function f of y. and this is our potential function. Yep. Right. Yep. Implicit differentiation. This really isn't that hard. I don't know what I'm like for time at the moment. What we do with this is we find some functions it's hard to get y on its own, so this is where this is useful. So we find d over dx of both sides, and any y's we use the chain rule. It's right there, 2y, we use the chain rule, so okay. That shouldn't be a 2y, that should just be a 2 dy over dx. We rearrange to get dy over dx on its own, and this is your answer. So, we've got an example. Find equation of the line tangent to 2y squared plus sine x equals 3 at 0, 2. Now, like I said, we differentiate both sides with respect to x. Yep. So, if we differentiate this, this will give us 4y dy over dx plus cosine x equals 0. So when you differentiate constant, you get 0. Yep. So then we do a bit of a rejig, move cosine over, move the 4y under, and you'll get dy over dx equals minus cosine x over 4y. Now, if you should remember, this was A level. The equation of the line is y minus y1 equals mx minus x1. We put our values in, 0, 2, we put our 0, 2 into here. Cosine 0 is 1, so we get minus an eighth. And then we rearrange it to get y on its own, so we get y equals 2 minus x over 8. And I think that's the last slide.